Hello students, and welcome to the pre-lab video for friction. You know, if we have an object and it rests upon a surface, in my case this block of wood here, we might apply a force to try to move the object, and it will only move when we apply sufficient force to finally break it free and move it. And we say the force right at that moment when we get it to move is equal to a force that opposes us, we call the force of static friction. And a very good model for the force of static friction is that it is directly proportional to the normal force acting on the object. Well, when the object is just lying on a flat surface like that, the normal force is just the weight of the object. So the constant of proportionality then between the force of static friction and the weight of the object is something we call the coefficient of static friction. It's a unitless number, and its value depends upon the material of which the block and the surface are made of. Now suppose we have the object moving and we continue to pull it across the surface at constant velocity. The force that opposes us in that case we call the force of kinetic friction, and it turns out it's slightly less than the force required to break the object free, the force of static friction. Again, the force of kinetic friction is directly proportional to the normal force or weight of the object, the constant of proportionality being the coefficient of kinetic friction in this case, and its value will be slightly less than the coefficient of static friction. So today I want to talk about a lab setup that will allow you to measure these coefficients of friction. We have the inclined plane here, and of course we have the block I've already shown you with a string attached. There's a pulley on the end of the inclined plane. You'll need a mass hanger and these slotted masses varying different values in grams that we use, and you've seen them in the lab before. So it's kind of simple. You'll first begin by just putting the block on the inclined plane with the plane not inclined. It will just be at 0 degrees. You'll attach a mass hanger to the end. And you can even put some mass on the block to make it a little heavier. It's not a bad idea. So the idea is to add just enough mass to the hanger to just get the object to move. So I might try doing that here. And of course we could add a lot of mass and get it to move immediately, but the idea is to add just enough to approach just the value that you need to move it. So you're going to want to add lighter and lighter, lesser and lesser masses as you begin to accumulate mass here, so you can get it just at the point where you have just enough mass to move it. So I'm doing that here, and so I do believe I have just enough to move it, as you see right there. So we say right at that point the weight on the hanger is our force of static friction. So coefficients of friction, they vary a lot depending upon the experimental setup. So you will want to repeat this many different times and get many different estimates for this coefficient of static friction. So you may want to repeat what I just did perhaps 5 to 10 times. And then we can even add more weight to our object and repeat the experiment again perhaps 10 times. The coefficient of static friction should approximately be constant for all those attempts, but you will have a relatively high standard deviation in the set for coefficients of static friction, so don't be surprised. We want to do the experiment many, many times. Well, what about the coefficient of kinetic friction? Well, here's a neat way to measure the coefficient of kinetic friction. You would repeat the same experiment. So I'll put the hanger back here, put some mass on it so it doesn't move right away. Take a little off the hanger here. And then you'll do the same thing. You'll slowly add mass to the hanger until you get it to move, but this time you will tap on the edge of your object with a pencil like this. And in this case, find the mass for which you get motion. And you can see it's already moving a little bit. So the weight I have on the hanger in this case, we say is equal to the force of kinetic friction. It will be slightly less than in the case for static friction. So we can then repeat the experiment many, many times, maybe as many as 20 times for different weights on the object, tapping on the edge with a pencil like that. And you'll get many different estimates for the coefficient of kinetic friction. It should be a slightly smaller value than the coefficient for static friction. You can take the mean of these and it will be your best estimate. So, well, why are we using an inclined plane? You know, we can find a coefficient of friction without using the hanging mass, just using the nature of the inclined plane. So you're very familiar with the effect of having something on a surface like this and knowing that if you incline it to a certain point, eventually the object will slide down the plane. We can use that effect to also estimate coefficients of friction. Let me tell you a little bit about the inclined plane. You can measure the degrees of the inclination by looking at the scale here. There is a screw here that allows you, when you get it to a certain point, to tighten it down, fix it at that point, and then you can later come and determine, hey, this is the angle for that particular point. A little bit about the pulley on the end. There's an adjustment right here that allows you to rotate the inclination of the pulley. For the first part that I just demonstrated, you want to have the inclination so that the string is parallel with the face of the plane. So let's just use the inclination now to just get the block to slide. We might have some mass on the block. It depends. And you might want to tape the mass to the block so it doesn't fall off when you incline the plane. But you know, we'll get to a particular angle. I'm going to bring it up, where the block just starts to slide. That's about right there. I would tighten down my screw. I can come around and determine the angle there, and we call that angle the angle of repose. And we'll learn in class, or you have already learned, that we can relate that angle through a trigonometric function to the coefficient of friction very easily. So we can compute right away, knowing that angle, the coefficient for static friction. How would we determine the coefficient for kinetic friction? We would repeat the experiment while tapping on the edge, the back edge, slightly with a pencil like that. Have your lab partner lift the plane up as you're doing this, and obviously it will slide down at a lesser angle than before, and you can directly compute the coefficient of kinetic friction that way. So you might want to repeat both of these with different values of mass or weight for your object. So that's how we would compute or estimate the coefficient of static and kinetic friction for a block of wood on a metal plane, two different ways, one getting the angle of repose and one just using a hanging mass to determine directly the force of static and kinetic friction. So you should be able to get a lot of estimates for these coefficients and find your mean. And there's not really a known value, but it should be a pretty good estimate for what the coefficients are in this case. So I look forward to seeing you in the lab.